everybody. I'm the greatest living inventor, and today we are doing my invention, a lightning rod and peer-to-peer against EMP and solar flare. So let me write it down. Lightning rod and peer-to-peer against EMP and solar flare. Okay, this is very long. It's 21 pages, so I'm not explaining anything. All the links will be in the description. I'm just reading really fast. It's like a practice in fast reading. Protect a country from an electromagnetic pulse EMP weapon and against solar flare natural EMP by using the old infrastructure in a new way. Lightning rod and peer-to-peer against EMP and solar flare. Here are my solutions against electromagnetic pulse EMP, either from natural source, Wikipedia, coronal mass ejection, or from a man-made weapon, Wikipedia, nuclear electromagnetic pulse. The sea urchin, lightning rod, and the peer-to-peer electric power distribution are my inventions. All the other stuff are not my ideas, just me putting two and two together in things that can save us from EMP. Part 0. Basic premise. Direct lightning hit is just as bad as EMP. This helps me think and research about EMP and solar flare because lightning was studied a lot more. I base this assumption on two sources. The first is the article about EMP in Wikipedia, where lightning is the first type of EMP and the only restriction is that lightning is longer. Lightning is unusual in that it typically has a preliminary leader discharge of low energy building up to the main pulse, which in turn may be followed at intervals by several smaller bursts. The other source is an article titled Differences Between Lightning and Nuclear Electromagnetic Pulse Interactions, end quote, by Edward F. Vance, Martin A. Uman, in IEEE Transactions on Electromagnetic Compatibility, Volume 30, Number 1, February 1988, page 58. Most comparisons of lightning interactions with structures have dealt with small bodies of roughly the size of aircraft. Page 2. These comparisons indicate that a severe, let's see if we're up to time, 4 minutes. Okay, roughly. We have 20 like this. These comparisons indicate that a severe natural lightning can deliver a larger peak current and more charge to a small system than can a HEMP, HEMP, high altitude nuclear explosions. Until recently, because of the lack of wideband lightning measurements, it was thought that the HEMP produces much larger rates of change of fields and it induces much larger rates of change of current than does LEMP, L-E-M-P, electromagnetic transients from lightning. However, recent wideband measurements of lightning current waveforms on a research aircraft as well as other evidence to be presented on section 4E, indicate that rates of rise of the same order of magnitude as those reported for HEMP, HEMP, may be possible for lightning currents and fields. End quote. In other words, for an average house, lightning is at least as strong as an EMP from a nuclear bomb. So, I base everything that follows on the principle that if it's good enough for a direct hit by lightning, it's good enough for a nuclear EMP. Solar flare is like EMP happening all at once above every place in that half sphere of our planet. Okay, part 1, home protection, sea urchin, lightning rod, one-way diode. Part 1, home protection, sea urchin, lightning rod, one-way diode. Many people want to catch the lightning and store its power in a battery. Wikipedia, harvesting lightning energy. As you can see in Wikipedia, the problem is not technical but economical. You don't get enough lightnings in the same spot, and each one of them doesn't carry enough energy to make it worth it. But now we are talking about saving lives, so we don't care about money. See, for example, this annoying video by Adam Savage, catches lightning in a bottle. Unimpossible missions by Adam Savage's tested. In parentheses, annoying because it only refers to another video which is unavailable. Close parentheses. Okay, page 3. And minute 7.5. And read more details about the unavailable full video here. GE, General Electric website, reports. Here's how you can catch a lightning in a bottle. Don't try this at home. How to catch a lightning in a bottle by Thomas Klenner in GE reports. Okay, so after we agree that it can be done technically and that the EMP/SF, solar flare, is just many lightnings over a large area all happening at once, then the first part of the home protection solution is trivial. Put many lightning rods, not just from above, but in all directions of the building, and ground them all to the earth. So this is what I call sea urchin lightning rod. How can we make it better? If you have one lightning, then the earth can take it, no problem. But if there are many lightnings, EMP/SF, it might be full of charge and the earth and electrify the house instead. So we need to do something similar to what Benjamin Franklin did. Use a Leyden jar. Wikipedia Leyden jar. You have a YouTube video that I'll put in the description. Web originals, Ask History, Ben Franklin and his kite history. So what I suggest each person will do is build a Leyden jar, which is very simple. Now I'm putting a few links. Shocking Science with the Leyden jar by the King of Random. Yes, you can make a Leyden jar with some simple stuff by Rhett Elaine. And make a super high voltage capacitor by Mehdi Sajjadar from Electroboom. In these demos, they make a small one, but you should make a big one. For example, a big bucket or watertight barrel. You should put it in a hole in the ground near the house and cover it with soil. And a thick electric cable protected with coating should conduct the electric charge from each lightning rod to its own Leyden jar. So how can we make sure it will not discharge from the Leyden jar back through the cable and into the house? In parentheses, Leyden jar is a capacitor that we just charged and it can discharge, close parentheses. We need to connect the last half a meter or so of the cable using a very thin wire For example, take an empty 1.5 liters family size soft drink bottle made of plastic. Puncture a small hole in the bottom and in the cap and pass the thin wire through them. What we are trying to do is called exploding wire method. Wikipedia exploding wire method. For example, here is a very long wire in the website phys.org, news 2011-11, extra long electrical arcs energy. So in a sense, the whole bottle thing is used as a one direction diode. After the air in the bottle becomes conducting plasma and takes the electricity into the Leyden jar, the bottle explodes and the electricity cannot go back, so the house is safe. This is why the bottle should not be buried in the ground, because after it explodes we want the plasma to scatter, and it's made of plastic and it's relatively small because we don't want anybody to get injured. Okay, page 5. Part 2, home electric storage, deep cycle battery, battery room. Part 2, home electric storage. Deep cycle battery. Battery room. Okay. Here is a quote from an equipment. Here is a quote from an experiment. What happened if in an EMP to the power plant destroyed, to the power lines shut down, and to over voltage protections burn? Quote, the Soviet scientists instrumented the 570 kilometers, 350 miles section of telephone line in the area that they expected to be affected by the nuclear detonation in order to measure the electromagnetic pulse effects. The electromagnetic pulse EMP fused all of the 570 kilometer monitor overhead telephone line with measured currents of 1500 to 3400 amperes during the 22nd October 1962 test. The monitor telephone line was divided into sub-lines of 40 to 80 kilometers, 25 to 50 miles in length, separated by repeaters. Each sub-line was protected by fuses and by gas-filled over-voltage protectors. The EMP from the 22nd October, K3, nuclear test, caused all of the fuses to blow and all of the over-voltage protectors to fire in all of the sub-lines of the 570 kilometers, 350 miles telephone line. The EMP from the same test caused the destruction of the Karaganda power plant and shut down 1000 kilometers, 620 miles of shallow buried power cables between Astana, then called Akmola, and Almaty. End quote. This is from Wikipedia, Soviet Project K, nuclear tests. The simplest solution is that each house in a hot area will buy, every time I say do something means ahead of time, buy solar panels, or in cold places wind turbine, or in moderate climate both. Every house will install them in his yard and on his roof and will provide enough electricity for himself. For example, people who live off the grid in Alaska do this. They have a diesel generator and diesel only for backup. Of course, we need to protect the sensitive parts, the electronics, etc., with Faraday cage and make sure that normally these solar panels or wind turbines are never connected to the grid, or else the EMP will fry them. Wikipedia, Faraday cage, page 6, minute for almost 15. Also, I suggest we protect even the non-electronic parts as much as possible using partial Faraday cages like metal grids or nets or meshes. For example, let's say we have rectangle solar panel on the ground. We can put it on 4 building blocks so it's above ground and stick 4 metal stakes close to the solar panel corners and tie a metal grid like the ones used in construction sites to the sun. So the sun can come through, but the EMP will hopefully electrify the metal grid and be routed into the ground with the metal stakes. A similar solution for the wind turbine is more complicated, but maybe we can sew a metal net like the ones people put in windows against mosquitoes around each blade of the turbine and improvise metal brushes that will rub against another metal net on the supporting pole that will take the EMP to the ground. Since the power from the sun and the wind is not available all the time, each house needs a battery to store all the energy during the day or when it's windy, and use it during the night or when it's not windy. Wikipedia deep cycle battery. Wikipedia battery room. But as you will soon see, this autarky, self-sufficiency, is not always ideal. What if, for example, you have a lot of area for solar panels, but you don't have cows and chickens, so you have a lot of electricity but no food. And let's say your neighbor has the opposite situation. They have a lot of tasty food but no electricity. To make a long story short, you want to trade electricity. So one way to do this is, of course, giving one of your full batteries to your neighbor and he gives you an empty battery in return. But what if you don't live next to each other? So part 3, city electric grid, peer-to-peer, pulse direct current. So let me erase this. So you see it's really rushed, and now I'm really not explaining anything. I'm sorry. We are in page 6 and we have 21 pages in total. Okay, so 15 pages to go. Okay, so part 3. City electric grid. Peer-to-peer. Pulse direct current. Okay, page 7. Wouldn't it be great if each house could give and take electricity from its few close neighbors? What if we could scale this up to a whole structure like an internet of electricity? As you know, the internet was built for exactly this problem. The USA was afraid that one or few bombs could take out all its computer communication if the control center was hit. So the internet is made so that there is no one center. There is the backbone, but in theory you cannot bring down the entire internet, because even if the best route to the destination is not possible, the message can always take another longer route through the computers that did survive and reach its destination. This is done using the IP protocol, which means Internet Protocol. Maybe a better example for most people is the peer-to-peer, which is abbreviated p2p architecture. Let's say you want to download a movie in torrent, but the movie is not stored in one central server, because then the law authorities will shut down the server computer down, but instead the movie is copied between many little people and each of them becomes a server, so the system is resilient. So we want to do the same with electricity. We want to keep it ourselves and pass it around, but we face two problems. The first problem is in the words of Gardy Hillhouse from Practical Engineering. Electricity cannot be created, stored, and used at a later time. The instant it's produced, it's used, no matter how far the producer is from the user, end quote. But if each of us will have an array of batteries at home, they act as an uninterruptible power supply, UPS. Wikipedia, uninterruptible power supply. The other problem is resistance. It's very hard for the direct current, DC, from the battery to move in the electric cable. This is because direct current, DC, travels through the whole volume of the cable, while alternate current, AC, travels along the surface of the cable, so it doesn't suffer from resistance. AC tackles impedance, but it's not as bad as resistance. Link: why use AC instead of DC at home by Electro Boom? But there is a solution that can solve all of our problems. It's a kind of current that is something between DC and AC, and it's called pulsed DC, or pulsating direct current, and anyway, in short, PDC. Wikipedia, pulsed DC. It travels all the time in the same direction, but it's like on and off, on and off, on and off. Now I will show you what made me smile in this one line in Wikipedia. Quote, pulsating direct current is used on PWM controllers, end quote. Why did I smile? Because when you check what PWM means, it means pulse width modulation. So in Wikipedia, pulse width modulation. And there Wikipedia has another very, very nice line, quote, along with MPPT, maximum power point tracking, it is one of the primary methods of reducing the output of solar panels to that which can be utilized by a battery, end quote. So this kind of special current, pulse direct current, can pass from house to house like AC, but without all the transformers that you need for the AC. Wikipedia, transformer. Okay, page 9, minute 22.5. In parentheses, because we cannot have transformers between each two houses to crank the voltage up and then down again, and parentheses. Okay, so where do we get this wonderful pulse direct current, PDC? So where do we get this wonderful pulse direct current, PDC? That's the beauty of it. It's a byproduct of the peer-to-peer, p2p system. On each node, which means each utility pole, Wikipedia utility pole, we will install, after the EMP, an electronic card that will be able to do the smart stuff, which means implementing the IP, Internet Protocol, of that city. Like if Alice wants to send a packet of electricity from her house to Bob's house, each smart card will know all the IP addresses and all the different routes the packet can be sent. Also, the electronic smart card will activate an actuator to make it happen. Wikipedia actuator. Each node works like a telephone switchboard. Wikipedia telephone switchboard. But instead of for phone lines, it's for electricity lines. Let's imagine the mechanism next to Alice's house. It has a round dial, like a clock's face, and the electrical cable from Alice is connected to the hand of the clock with the metal brush. And the hand on the clock can go round, but in our clock it doesn't show time. Instead, it just spins and spins endlessly. So remember that Alice wants to send a packet to Bob. Let's say in this example that there are 3 possible routes: through Carol, through Dan, and through Erin. The actuator pushes these people numbers, and let's say their numbers are 1, 2, and 3. So now each of these numbers get an electrical packet, and the electric packet comes in short bursts, which is effectively the pulse direct current, PDC. Page 10. Now suppose Carol and Dan's houses have burned cables from the EMP, but Erin still is functioning. Then Bob will eventually get electricity through Erin. To make this complete, we want to encode on each packet, like in Morse code, who it's from and who it's going to, just like the packets in the internet, and then we can track them better. One last thing you might see in Wikipedia about PDC. Devices and circuits may respond differently to pulsating DC than they would to non-pulsating DC, such as a battery or regulated power supply, and should be evaluated. But remember that in my scenario everybody is using their battery, which means what gets to your house is PDC, but inside your house you use DC. Okay, part 4, city grid protection, lightning arrestor, P2p switch, water pipes. Part 4, city grid protection, city grid protection, lightning arrestor, P2p switch, and water pipes. This is just to finish off the previous part. If you say, okay, what happens if there is another EMP? Does everything burns again? The smart cards indeed burn again. They are delicate. We need to make backup of copies of those, but electronic cards are cheap to make. But the expensive hardware of power lines is more robust because the grid is not all connected all the time. This is because the hand of the clock doesn't touch all the numbers on the clock all the time. Also, I suggest we use lightning arrestor, which is a bigger version of surge arrestor, and if there is a lightning, it takes it to the ground instead of allowing it to burn the wire. Okay, lightning arrestor. Okay, we finished page 10, and we are in 27 minutes 40 seconds. We're fine. So lightning arrestor in Wikipedia. Lightning arrestor's component, silicon carbide, was first made by Hutchison process from mixture of clay, aluminum silicate, and powdered coke, carbon, in an iron ball that you pass electricity through. So it's not expensive. You can see in this nice video of Edward Goodrich Hutchison in action. I guess it's a docudrama, dramatized reenactment, although the motion picture camera was invented in 1888, so maybe it's him. Dissolve.com, chemist Edward Goodrich Hutchison mixes coke clay royalty-free stock video footage, blah blah blah. Another option is to make the lightning arrestors from zinc oxide, which is made by melting zinc, and zinc is a pretty common metal with low melting point, so this can't be expensive as well. Not expensive. Yet, another option is the cheapest of all, to make a spark gap, which is like what we did in the plastic bottle for the one-way lightning rod to Leyden jar, but without the exploding wire. What if all of the power lines are down? I suggest that we then use something that is conducting and reaches each and every house, by which I mean non-plastic water pipes, meaning steel and copper pipes. Wikipedia, plumbing materials. This requires the population to be careful because, for example, in the night time the city will supply power over the water pipes. This protects children who might use the tap and die during the day. To use the plumbing, we need to isolate it from the ground, which is hard because most of it runs underground and inside walls, although a wall doesn't necessarily conduct to the ground. The water themselves contain ions and are conducting. Distilled water are not conducting. But if we use the pulsed direct current, PDC, the current will flow on the pipe, the outside, and not in the water, the inside. Page 12. Since pipes need to be sealed for the water pressure, we cannot disconnect them and connect them in their present condition. So this requires reinforced plastic nodes to be used between the houses or between every few houses at max, so that we have individual blocks of emergency electrical distribution. Okay, part 5, food transport and cooling, all trucks, heat pipe. Part 5, food transport and cooling, old trucks, heat pipe. Okay, so the people have electricity, but where will they get all their food and water? Everything is moved by trucks, but the problem is that all the new vehicles have a computer and electronics, and the EMP will fry that. So again, it's pretty trivial, but the solution is to save as many old trucks from 1980 or earlier in good condition that we can maintain them in good condition. We also have to take them for a ride once in a while, so their battery is full and so on. Mechanics.stockexchange.com, questions 18148. What damage does a car suffer if not regularly used? The rest of the time, which is 99%, they should be in a special emergency garage, which are made with metal walls, which will act as Faraday's cage and protect the trucks. On the trucks, there will be one solar fridge, or more if possible, and on the roof of the truck will be mounted the solar panels for the fridges. Wikipedia, solar-powered refrigerator. Page 13. But where will we store all the supermarket stuff after it reaches its destination? I suggest next to every existing supermarket, we dig ahead of time a small tunnel that we will use for the storage of refrigerated foods that need to keep cool. The temperature of few meters below ground is already pretty cool, which will save energy costs in the long run. The extra cooling will be done passively by heat pipe, which is a technology that doesn't require energy. It works by itself. The heat pipes will make the heat from the tunnel through the ceiling of the tunnel, will take the heat of from the tunnel through the ceiling of the tunnel to the surface. We should use a liquid in the heat pipe that boils in a lower temperature than water. So we should use either ammonia, it's 213 to 373 Kelvin, or alcohol, methanol is 283 to 403 Kelvin, or ethanol, which is 273 to 403 Kelvin. Wikipedia, heat pipe. If you want to see a video of how heat pipe works, not the liquid we will use and not the temperature range that we will use, see for example here, How to Make a Heat Pipe or Solar Heat Collector by Robert Murray Smith. Or here, Homemade Heat Pipe by Nick Moore. If you are worried about freezer, it's also possible, but then we need solar power during the day and the battery during the night. Okay, page 14. By the way, according to Wikipedia, Augustin Mouchot produced ice using concentrated solar heat in 1878 at the Universal Exhibition in Paris. Wikipedia, solar-powered refrigerator. Okay, part 6, oil replacement, microwave and laser, electric car conversion. Part 6, oil replacement, microwave and laser, electric car conversion. But I hear you asking, what will the trucks run on? And here we get to the last section. The trucks will run on electricity. I know I said we will use cars from 1980s or earlier, and back then there were no electric cars at all. So what we will do is turn the trucks in their special garages into electric trucks. I don't know anything about mechanics, but there are many videos on YouTube about this, so I'm sure it's possible and affordable. Example 1, electric car conversion from gasoline to electric car in one video by George Bolton. Example 2, Carman Gia conversion to electric, the process by Bots Fine Vids. Page 15. But what if there is not enough surface for solar panels or wind turbines for all the things we need? Like, for example, if we want to need to manufacture something which requires great heat, or have to drill for resources, and etc. Then we come to the last part of my plan, which is help from neighboring areas or even other countries. This is done by laser or microwave beams. Wikipedia, wireless power transfer, hashtag far field radiative techniques. Let's say we have a mountain between neighbor cities, then on top of it, we can build a bunker with, now a link, NASA wireless power transmission demonstration. For an update about this, see here. History and status of beamed power technology and application at 2.45 GHz by William C. Brown Rayton Company. ntrs.nasa.gov, archive NASA, casi.ntrs, nasa.gov, something. Which includes this nice sentence. The Rectena survived and was operable after a direct lightning strike on the tower in 1980, and which destroyed equipment on the ground. It's hard to know, now it's me again, it's hard to know what's the current capabilities of such technology, because I get the feeling it didn't advance at all. The US Army is making pain rays for crowds and weapons against drone swarms. Page 16. All the drone needs is a little mirror to defense and even take out the weapon. Popularmechanics.com, military weapons, blah blah, laser microwave weapons. Okay. Speaking of mirrors, I'm thinking now that if an area is isolated without electricity and it doesn't have a lot of sun, let's say Wikipedia Long Island solar farm, this can give New York very little electricity in December. What happens if the EMP strikes in December? So my idea is to equip airships. We can fill the balloons with helium so that we don't get the Hindenburg disaster all over again, and zigzag the light with huge mirrors from more sunny areas like Florida. Wikipedia airship. It would be even better if we can create concave or a convex mirror, possibly by pasting small mirrors on a lightweight surface, maybe PVC. So we have concentrated beam of light which might be easier to point to the next solar relay, which is the next Zeppelin on the line. By the way, I just bumped into an article in Wikipedia which referred to Wikipedia thermal energy storage, hashtag molten salt technology, which can help a lot in the section that we talked about how to store the solar energy. This can be like a battery for the whole city and used for bigger clients like industry manufacturing or resource excavating and things like that. Okay, now space, future time. Okay, so space. This is in the future. About harvesting solar power in space, sadly it's far in the future. I gather it from Japan saying it will be in 2030 and more recently China saying it will be in 2050. Wikipedia, space-based solar power. http phys.org news 2009-11 Japan eyes solar station space. Forbes.com cites Scott Snowden 2019-3-12 solar power stations in space could supply the world with limitless energy. Forbes.com cites Scott Snowden 1935. China plans to build the world's first solar power station in space. In YouTube, Space Solar Power Project by Caltech. Okay. When we do have the ability to transmit and receive energy from space, I think each country could have agreements with countries on the other side of the world, like here. www.antipodsmap.com. So, like the other side. So, like New York and Australia can be in an agreement, and Russia can be in an agreement with Argentina and Australia and so on. In case of a solar flare, half of the globe suffers more and half of the world suffers less. So if you are in the lucky half, then you can help your unlucky friend country that you are in a mutual contract agreement with. What can the lucky country do to help its friend? Let's say that New York is completely fried by solar flare, but Australia survived this solar flare. And let's suppose we can transfer power to and from satellites. Okay, page 18, minute 43. Australia can divert half of its energy to send it to New York via satellites and can create a chain of relays like the airship's idea, but over long range and with microwave or laser. Okay, now high voltage direct current, present time. High voltage direct current. Okay, this is present time. High voltage direct current, in Wikipedia, high voltage direct current. Most HVDC links use voltages between 100 kilovolts and 800 kilovolts. A 1100 kilovolts link, 1100 kilovolts link in China was completed in 2019 over a distance of 3,300 kilometers with a power of 12 gigawatts. With these dimensions, intercontinental connections become possible, which could help to deal with the fluctuations of wind powers and photovoltaics. Notice the nice word, intercontinental. Okay, part 7, water and waste. Go back to gravity ASAP. Okay. So part 7, water and waste. Go back to gravity, ASAP, okay, as soon as possible. www.afpc.org, uploads, documents, EMP, primer, final.pdf. I'm quoting. Traditionally, water infrastructure includes tunnels, pipes, and other water delivery systems, was gravity fed by design. More recently, however, a large portion of this infrastructure has become electricity dependent. The pervasiveness of the electric pump has allowed cities to exist in areas previously uninhabited due to the lack of gravity-fed water. However, disruption of electricity as a result of an EMP attack would cause the failure of any systems reliant on such machinery, including those associated with water purification and delivery. Water sanitation processes, which are vital for human survival, would also be impacted. Page 19. I didn't think about it, but this is super serious, and especially with all the diseases that non-functioning sewage will cause. The only solution I see is to evacuate cities that rely on electrical sewage pumps into other cities and subsidize the relocation for them. Okay, today. There is no way that people will be able to use chemical toilets on for a long time on a scale of a whole city. Composting the feces, etc. also requires energy and space for gardens, etc., which a dense urban area simply doesn't have. In the third world, people use human waste, burn it for energy and make bricks, etc. But these people don't have the density of an American city, and where they do, they face a lot of disease, like in India, for example. The water problem is multiplied if we add dehydration from diarrhea. The only way to go is to undo what you have done. Relocate the people now before the disaster strikes. Okay, part 8. A hypothetical idea, anti-resonance. Okay, there is a thing called anti-resonance, which means is a special way of resonance where one oscillator moves a lot and the other moves very little. Wikipedia, anti-resonance. In this video, it's in a mechanical system, but the same can be done in an electromagnetic system. Okay, so the video is 2 degrees of freedom spring mass system, anti-resonance by UBC, okay, University of British Columbia, MEC, okay, mechanical, DAL. I don't know what is DAL, so you have the link in the description. Okay, page 20, minute 50, we're good. Here are 2 cool examples of electric synchronization. This is not anti-resonance. Huygens synchronization, electrostatic oscillators by Ami Versano, and Huygens synchronization with revolving balls by Ami Versano, also YouTube. please notice that this is not anti-resonance. I just want to visually show electric things has properties of coupled oscillators, like two pendulum clocks that are hung on the wall next to each other, and after a while they synchronized to each other spontaneously. Wikipedia on anti-resonance in electrical engineering. Anti-resonance in electrical engineering. In electrical engineering, anti-resonance is the condition for which the reactance vanishes and the impedance of an electrical circuit is very high, approaching infinity. In an electric circuit consisting of a capacitor and an inductor in parallel, anti-resistance occurs when the alternating current line when the alternating current line voltage and the resultant current are in phase. Under these conditions, the line current is very small because of the high electrical impedance of the parallel circuit at anti-resonance. The branch current are almost equal in magnitude and opposite in phase. Wikipedia, anti-resonance. The way I understand what Wikipedia is saying, so if we put two identical power lines instead of one in the same direction and connected to each other, and they both get the same input, the EMP, but in a specific phase gap between them, then one of them will be conducting and one will be a conductor and one will become insulator. So the conductor one will fry, but he will sacrifice himself to save the insulating one. Then after the EMP passed, the former insulating power line that survived will get his normal conducting properties back, because it is no longer coupled to anything, and we will use it for electricity. How do we make this phase gap? Okay, this gap. This I hope engineers can calculate, but I guess we need a capacitor and an inductor in parallel, like Wikipedia said. If this isn't possible, then we need to assume the EMP will come from above and make a lightning rod with specific length that the engineers will tell us, and so one wave will travel a distance x and the other wave will travel a distance x plus lightning rod length. And if we get the lightning rod length just right, it's like you make an antenna for your field radio from a piece of wire in the right length for the radio wave that you want to transmit and receive. Another concept, if it's possible to implement logic gates in high voltage, again I don't know how, you need to ask an engineer, is to make an OR, okay, OR, logic gate, putting two wires, and if they both conduct, they don't pass electricity. This again assumes that without the lightning rod, the EMP will hit the two wires at roughly the same time. On the other hand, if we just use one of the wires, then the OR gate will allow the electricity to pass. Perhaps using something like this: high voltage DC circuit breaker. Wikipedia, high voltage direct current, hashtag high voltage DC circuit breaker. Okay, so that's it. So we finished page 21, and it's about 55 minutes. So it paid off to rush. So thank you very much. I hope it was clear, even though I didn't explain much. And thank you very much. And this was my invention, and I'll see you in my next invention. Thank you very much. Bye-bye.